Hi everyone, today we're going to be looking at the Productivity Open P1AM Industrial Arduino math instructions. Now, detailed information contained in the video can be found at accautomation.ca. A link has been put in the description below. If you have not watched the other videos yet, there will be links in the description below that will start you at video 1. There will be links to the rest of the videos in the series as well. So up on my screen I have productivity blocks open, and if we look under the math instruction we'll see several different instructions here. And the first one that we look at is the arithmetic operations. And in the arithmetic operations, if you click on the down, you'll see that we can add two variables, we can subtract them, we can multiply, we can divide, and we can find the remainder. So that means after the division, whatever that remaining value is, that's what it'll be displayed. So example, if we take 7 divided by 5, the remainder using this instruction would be 2. So that is our arithmetic operations. So let's just go back there and look up the next one. And the next one is actually going to be our compound operators. And compound operators, you'll see we have different samples depending on what we have. And you can see here we can do the plus that we have here. So it's adding the value here to our variable here. We have our subtraction. We have our multiply. We have our divide. Then what we do is we get into the bitwise operation. In this case here, this is the bitwise AND. So this is like masking of variables. Then we have the bitwise OR. So we're ORing the variables. And then we have the bitwise exclusive OR, or XOR. So that means that both have to be different for it to be on. So that is our compound operators that we have under our math instruction. Next, what we have is our absolute. And our absolute term just means it's absolute from 0. So for example, if I say it's 5, absolute 5 is 5. If I say it's minus 5, then the absolute value of minus 5 is 5 from 0 still. So what it is, it's a negative 5, which makes it a positive 5 when we look at it. So that's absolute. Next under math, we have power. So we have a base unit and an exponential. So if we have a base of 10, exponential 3, we have a value of 1,000. So that we can do complex math with those variables. Next we have our square root. So we take a value of 16, we do the square root, we're left with the value of 4. Next we have our sine, we have our cosine, and we have our tangent. Now these all have to do with the right angle triangle and finding the angle of it. So if we look under the sine, you can actually see you can switch these to different ones. So even though they're listed as 3 individual ones, you can actually list them all separately. So that is under the math again, sine, cosine, and tangent. Then we have random, and random gives me a random number between, in this case here, I have a minimum of 0, maximum of 10. So it's a number between 0 and 10 that we can actually have. And you can see our standard information. So this just creates a random number for us. So that's under random. And we'll do an example of that in just a minute. Then we have a map. And map, what it does, it's actually scaling values for us. So for example, this here, we're going from 0 to 1023, and we're going to scale it from 0 to 255. So basically a 10-bit resolution down to a 8-bit resolution, for example, on our analog signal. So we can actually do that with the map. So this is going to be very useful when we look at analog signals going into the Arduino controller. So that's map. Next, what we have is we have constrain. And constrain means that our value here, the lower number must be equal to or greater than this number, and the high number has to be this number or less than. So that's constrained. So that means that we're always guaranteed that this output value is going to be a certain number. So there are our math instructions that we have available to us through the Productivity Block software. And this software really helps us out when we go into some programming writing, and it automatically converts to our C++ code using the Arduino, and then we can download to our controller. So let's just close that down. And I have an example up here of our math instruction. So the first thing we're going to do is we're going to start this up. We're going to set our monitor. Then we're going to get our C++ code. We're going to say our write analog resolution is going to be 10 and our read analog resolution is going to be 10. So it sets up our analog values like we did last time. Then what we're going to do is we're going to get our analog value, and we're going to look at pins D0, which is our first digital output, and it's going to get the analog value from A1. And what we're going to do is we're going to map it or scale this so that instead of going from 0 to 1023, we're going from 1023 to 0. So we're just inversing that logic. And then the next line here, we have our second digital output, and we're going to set our analog, and it's going to set to A1. So what we'll do is we'll have two pins. They're going to do the exact opposite. One's going from 0 up to the maximum. We're going to throw the maximum down to the minimum based on our analog input signal. So they should just oscillate back and forth. Then what we have is a CPU switch. When it is on, what we're going to do is we're going to get an integer. We're going to set an integer to a random number between 0 and 1024. Now that random number is going to be between 0 and 1023 because it's always one less than the maximum. So that is a 10-bit resolution of our analog, which goes back to our analog resolution that we have up here. And then what we do is we print our number onto our monitor, and then we set to the new line. Then we also set pin number 2 using pulse width modulation that we learned last time into the digital output, and that will actually show us a variable each time that, as long as the CPU switch is on, it's doing a random number. So what I should do is getting like a pulse or a vibration or a different intensity light each time that it generates a new random number for us. So that is my program. And so let's take a look at our actual hardware that we have here. And when we look at our hardware, here is our P1AM GPIO. This is my P1AM-100 CPU unit. And we are connecting through our serial monitor using the USB connection here. Then we have our positive voltage going down to my potentiometer. Potentiometer is going back into A1. Then we have D0, 1, and 2 going to my LED lights here, 0, 1, and 2. So if we take a look at the actual wiring of this unit, let's call that up. Here it is right here. So there's A1, there's my potentiometer. Then D0, 1, and 2 go to my LED lights to show my indication. So that is the wiring diagram for our circuit. So next, let's verify this program. When we verify it, it automatically compiles my C++ code for me. And then once that code is compiled, then what we'll do is we will upload this to our actual controller. And then once it's uploaded, what we can do is then run the code. So now you see we've done finished transferring it or uploading that data. So we can now hit the serial monitor, and we make sure that our baud rate is set for 115,200 like it is. Now let's take a look at our actual program. And the first thing we'll do is we'll turn on our multimeter here, just so that we can measure our analog coming in. So as we said before, the first two, if I turn the switch all the way over to the left, so at 0, then we have that fully on. If we turn it right up, we have the other one on. So it just operates equally, or the opposite of each other. So you see we have 3.31. Output number D1 operates with that voltage. Output D0 operates the opposite way. So when we're at 0, we have full voltage on here. So that's what our map does on our math instruction. And then we can kind of equalize that out. We can put about 1.5. And they should be relatively the same LED light source. Next, what we can do is, since we have our monitor up here, we'll turn on the CPU switch. When we do, what you'll see is that we are randomly generating different numbers for our pulse width modulated output signal on our D2. If I turn off that switch, then right now we're reading at 659 of the 20, so it's about half the frequency, or half the light. Turn it back on, turn it off again, and again 4, there's 9, it's a little bit brighter. So as I go along, and I can randomly find, where it's going to be. There's 106, so it's just about out now. So if you enjoyed this video, please hit the like button below. If you have any questions about the video, please leave a comment below and I'll do my best to answer it. If you want more information about us, or you want our free ebooks on numbering systems or robust data logging, please click on the link in the description below to get it. A new video is put out every Monday, so make sure you hit the subscribe button to get more videos like this in the future. Remember to click the bell beside your subscription to actually receive those notifications. Thanks so much for watching. I'll see you next time. Stay safe.